All right, so here we're going to look at how to solve a secant graph. So one of the first things we need to realize is that if we're going to graph 1/2 secant stuff minus 1, first thing we need to do is we need to graph y equals 1/2 cosine of stuff minus 1. So let's go ahead and write that in here. And the reason we're doing this is because secant and cosine are reciprocal functions of each other. Okay. Now we're gonna graph this in levels. So we're gonna start off with graphing this portion right here, and then we'll take the y values and multiply by 1/2, and then we'll move all the points down by 1. So when we start this out, the first thing we need to do is we need to go ahead and solve for the period. Now the period for this graph is going to be the same as the period for this graph. So we start off with a base period of 2 pi, and when we divide it by the number in front of theta, then we get 1 pi. Now, when we look at our period that is 1 pi, we look at our graph, and the graph's been broken up by pi over 3s, so this represents 3 boxes. Okay, so if one period's 3 boxes, then the start of the graph to the end of the graph is going to occur in 3 boxes, or 1 pi distance. The next thing we have to solve for is we have to go ahead and solve for the phase shift, which is our starting point. So if we look at this right here, we're going to set this equal to 0. So my PS represents my phase shift. Okay, and we're just going to solve for theta. So this is going to be a pretty easy process. We're going to go ahead, we're going to add 5/3 to both sides, 5/3 pi. Okay, and then we end up getting 2 theta is equal to 5 pi over 3. When I go ahead and I multiply everything by 1/2, we end up getting a phase shift. Okay, so I'll write it up here, run out of room. We'll get a phase shift of 5 pi over 6. Okay, so when I look at that in the context, like none of these are boxes or pi over 6. However, each half of a box is pi over 6. So this tells me if I'm going to do 5 pi over 6, then that's 5 halves of a box. So that's really going to be 1, 2, 2.5 boxes over is where I'm going to start. So this starts at 2.5 boxes right. Okay. So when I do that, it starts 2.5 boxes, and instead of starting at 0, 0, or just an x-intercept, because cosine, if we go back, one of the things we need to look at is the fact that we should know that y equals cosine of x looks like this right here. Notice that the cosine of 0 degrees is 1. We go ahead and we graph the rest of it. The end point, when we're at 2 pi, is going to be over here. Halfway between that, I'm going to be down at -1, and then I got my x-intercepts right here. So we just need to have a basic understanding that this is what cosine looks like. So when we start our graph over here, we're going to go over 2.5 boxes, okay, and we'll go up at 1. So that's going to be my starting point. Now remember, I'm only graphing, I'm doing it in pencil right now. I'm going to go ahead and graph that right there. So I do 2.5 boxes. Now I go back and I look at my period, which is 3 boxes, or 1 pi over. So I'm going to go over 3 boxes. 1, 2, 3. I'll put my end point right there. Because remember, if we look at this graph up here, its starting point and its end point is 1 period in distance away. So if this is 3 boxes over, then a box and a half over is going to go ahead and be this point down here. So I go a box and a half over, so half a box, and I'm down at -1. Okay? Now because the distance from this starting point to this midpoint is 1.5 boxes, then I'm going to go 75% of a box over, or 0.75 boxes over, and it's going to be my x-intercept. And I'm going to go 0.75 boxes over this way, right there. So right now, what I've graphed is I've graphed this right here. I could connect it, okay, and it'd look like this right here, see? Now, however, I need to go ahead and I need to look at this 1/2. So let's take into account this 1/2 now. The 1/2 is going to take any coordinate that has a y value, and it's going to multiply that y value by 1/2. So this one right here has a y value of 1. When I multiply it by 1/2, it drops down here to positive 1/2. So then I'm going to go ahead and I'm going to erase that point right there. This y value is 0. Any x-intercept has a y value of 0. So when I multiply this y value by 1/2, it's 0. I take this y value, which was -1. I multiply it by 1/2. It goes up to -1 or negative 1/2. This one doesn't change. This one goes from here, it goes to positive 1/2. So now, these points right here, I would have graphed all these right here, okay? Now one thing I'm gonna do is that when we go and try to graph the cosine graph, sometimes like the curve doesn't look very nice. So what I would usually do in the cosine graph is I would go ahead and graph an extra point right here, okay? And so how to find that point is you would go from the starting point and you would go to that first point, that first x-intercept right here, and just look at how many did I have to go over and down, and just do the same thing over this way. So here I went over 0.75 boxes and I went down. So I'd go over 0.75 boxes and I'd go down. So it'd be like right about here, okay? So now I've graphed all of this except for moving all the points down one, and we'll do that in a second. But since our goal here is not to graph this, for the most part, is to graph this right here, any place that we have an x-intercept now, before we vertically translate it, we're gonna turn into a vertical asymptote. So I'm gonna have a vertical asymptote here, I'm gonna have a vertical asymptote here, and I'm gonna have a vertical asymptote here, okay? Now, I'm gonna take all the points, and I'm gonna move them down 1 point. So this gets moved down here, this gets moved, this was at 1/2, so it gets moved down to negative 1/2. This gets moved down here, this goes down here, this goes right here, and I can drop that one down, don't really need it, but I can. And then I'm gonna go through and I'm gonna erase these points. So it's really important to do these in pencil as you're going through the questions, so that if you make a mistake, then you can just easily erase it. Or as you go from one step of the problem to the next step of the problem, you don't have to have a bunch of colors overlapping each other. So now what I'll do is I'm gonna connect these. I'm gonna connect them in pen right now. And notice how much easier it is to graph when you have that extra point over there, instead of trying to connect these points, which look like they're almost in a straight line. Now, we have finished graphing this right here. So the last thing that we have to do is we will now look at our maximum points and our minimum points. So this one right here, this one right here, and we will now graph little, what looks like parabolas going up. And we will just make sure that they do not cross our vertical asymptotes. So by doing this, we have now graphed this right here.